Let's begin with question number 9. Let's move this question to whiteboard, please. And we shall begin. So the diagram shows a semicircle with center O and radius is 8. So when they say the radius is 8, we can say that OA, OB, and OC are A down plus seg naught. And then angle AOB is given in radians. So in the case where theta equals to 1, that means 1 radian, calculate the area of the sector BOC. Okay, they want BOC. So the area, the radian is 1 here. This will be, pi radian is 180 degrees. So pi minus 1. Okay, so this is the angle that is facing the sector BOC. So that's why we need to calculate that part. And then the formula for the area of sector, so area of sector BOC will equals to half r square theta. If we use this formula, theta must be in radians. Okay, please take note. So therefore now we substitute the radius is given as 8. So half 8 square. Then the theta is what? Pi minus 1. Okay, the theta is pi minus 1. Okay, let's calculate this, please. Let's put in the calculator. We get the answer as roughly, let's say 68.5. 68.5 units square or cm square. Okay. Let's do the next part, please. So the second part is you find the value of theta for which the perimeter is equals to half of the perimeter of the sector BOC. It means perimeter of sector AOB is half. So the keyword here is perimeter. So let's look at it a bit more closely. So the perimeter is the second part of sector AOB is equals to half of the perimeter of sector BOC. So the sector AOB, if you look at it, the perimeter is just OA plus OB plus AB, but the AB is an arc, this part. Please take note. So this one is the OA and OB, which is the obvious part, the straight line. So this is the perimeter you're talking about. So that's why I wrote it like that. And then let's look at this side, please. So this side is going to be half of perimeter of sector BOC, which is made up of this part. Sorry, there's a bit of a nice trace on it. Okay, so BC with an arc, and then OB and OC. Because if we draw the straight lines, these are straight lines. Now it is a curved line. Okay, length of arc, so we normally denote like that. And therefore now we can calculate using the length of arc formula, which is only for the AB and the BC part. So length of arc is what? Length of arc will be half r theta, isn't it? So half r squared, sorry, there's no half r theta. So this half r squared theta is the area. I'm thinking in Malay, S is j theta, jari and this thing, because you still learning it in that form. So length of arc is r theta. Okay, now let's just substitute, please. OA, OB, and OBOC are what is it? Radius. So 8 plus 8 plus r theta on this. So 8 times theta. And then on this side, because the angle on this side is theta, this will be, please take note, will be pi minus theta. Okay. So one other thing to observe. So the BC will be 8 of, okay, just change the color for that to emphasize, r theta. The theta is pi minus theta. And then this is plus OB and OB and OC, sorry, 8 plus 8, like that. Okay. Then we just solve this like normal, this algebra. So let's say we solve this, this becomes 16 plus 8 theta, like this one half of this. So 4 of pi minus theta, I just half it inside. So this just becomes 8. 16 over 2 is 8m. Okay, let's just open up the bracket and resolve it. Minus 4 pi plus 8 like that. Aha. This is supposed to be theta. Typo. Okay, minus 4 theta plus 8 like that. So we move all the theta one side. So 8 theta plus 4 theta. And on the right side, we move all the other things. So 4 pi plus 8. Okay. And then minus 16. So this becomes 4 pi minus 8. And then this side becomes 12 theta. Oh, then we realize the theta in radian is 4 pi minus 8 over 12 dividing by 4. Up and down, 4 times 2, 4 times 1, 4 times 3. Either we can leave it like that, or if we want to change it, because this is in radians, so I think we leave the answer because they say theta is in radians at the start. So we can leave the answer like this. This is the exact answer. But if you want to get the decimal approximation, pi minus 2 like that on the calculator divided by 3, it's roughly about 0.381 radians. Okay, let's go for the third part, please. So in the case, so I'm just removing each time because each case is not related to the earlier one. The numbers seem to be changing with different conditions under the same diagram. So in the case where theta is equals to 1/3 of pi, please take note that pi radians is 180 degrees. So though we have to supposed to calculate all this in radians, sometimes we can take a look at the angle, because this could be special angles, like in this case, in degrees. What is it in degrees? So pi radians 180 degrees means this is about 60 degrees. Because 60 degrees, it's a special angle, easy to think. That's the reason. It's not necessary, but it helps if it helps. Okay, let's go for the third part. So like this, show that the exact length, the word exact, it means the pi or circle will not be approximated, of the perimeter of triangle ABC is this. Okay, let's just join a little bit to see the triangle ABC. Aha, there we have the triangle here. One of the key observations is that this is an angle in a semicircle. They didn't mention, but we ought to know now. This is 90 degrees. That's one of the keys here for this question. Okay, then this is angle at the center, which is AOB down here. Aha, it's twice the angular circumference. That means this angle will be, this is the first thing I'll do, is theta over 2. So this part is given as pi over 360 degrees means, I just put 60 degrees, not easy to think, and this is 30 degrees. That means this also means that this is 60 degrees. You see that? So it's a nice coincidence, isn't it? So angle BAC is 60 degrees or pi over 3. And then angle BCA is 30 degrees or pi over 6, half of that. Okay. Okay, now we have enough knowledge on this part. So let's try to, what we say, calculate the components that are needed. Okay, the perimeter of triangle ABC. Okay, how do we calculate? So we need to calculate AB and then BC and all that. So if you look at this triangle ABO now, under this, what we say, those markings, I'm just going to draw it again here so that it's a bit more clear in case it is not the diagram, just a representative diagram like this. So this is B, this is A, this is 8 cm, this is O, the radius. And then you realize that this is 60, and this is already 60 by those geometry things. Then this automatically 60. So it's actually a hidden equilateral triangle from which we can deduce that AB is equal to OB of the radius, which is 8 cm. Aha, we found AB already. Okay, let's try to find the other part. So AC is the other direct calculation here. Okay, AC is AO plus OC. AO and OC are both radius, so 8 plus 8 or 16 cm. So the third one that we need for the perimeter calculation is the value of BC. That proves a little difficult. But if you look at it carefully, we can see a triangle like this with the angles marked as shown. Oh, okay, let's take a look at it, please. So this is A, this is 90 degrees, this is B, this is C. So this is 60 degrees, this is 30 degrees. Look at the diagram. So I'm going to use the 60 degrees, let's say, to get the either one I can use. So this is opposite. Please take note. The BC is opposite. All right. So the BC is opposite to this, and then AB is 8, and this is AC is 16. This is hypotenuse. Okay, that's adjacent. So either one we can use. So I'm going to use sine of 60. Easy to think in terms of sine. So let's write that plus. So sine of 60 will equal to the sine 60 opposite over hypotenuse. So katawa BC over AC. Okay. So BC is the one we're going to find. So AC is 16. So in other words, BC is equals to 16 sine 60. So this is why the exact value comes into play. So I'm just going to do another diagram here, the corner here, special triangle diagram, because for exact values, we need to kind of memorize this triangle or rather understand it, which is it's a 90, 30, 60, 90 triangle. So it's 30 degrees, 60 degrees. So this will be root 3 like that. So sine 60, as you can see in this triangle, is it's same ratio, opposite, and this one. Oh, so that means it's going to be something like sine 60, I write it below it. Opposite over hypotenuse. So root 3 over 2. So the rest of it is from the question. It's a factor, similar triangles. So when you multiply this, then this becomes 8 root 3. Okay, now we have the three values. Let's add them up, please. I'm just going to circle them and add them up for the final calculation. This is AC, and we have BC. So finally, we calculate the perimeter of triangle ABC, all straight lines. So AB plus AC plus BC. AB is 8, AC is 16, and 8 root 3. So when you simplify this, it's easy to see that. Yep, 8 plus 16 is 24, plus 8 root 3. Then just copy as how they wrote, put a bracket like that, CMQED. End of proof. So that's one advantage of this kind of questions we can check because they ask you to prove it. So we can check that immediately it's correct. Thank you.